say the statement is true as such that the statement is firstly correct and it also can be trusted. But most statements are limited in scope and not necessarily absolute and universal, because we have different disciplines, and different disciplines have different scopes, different goals. When it comes to engineering, for example, and we know that engineers use the applied physics and mathematics to solve real-world problems. But the goal is different from science, because science tried to discover the truth. And if we consider a reservoir engineering discipline, where engineers try to study a giant rock, a piece of rock, and the surface, the surface. What they actually try is to understand that reservoir and how fluid flow inside this giant reservoir. Let's say that we have an oil well, and the fluid flow inside that reservoir is toward that well. And this is gonna change the pressure and the other properties of that reservoir. And as a goal of engineers, is they try to predict the performance of that reservoir, which involves solving equations, and from fluid mechanics that are almost impossible to solve analytically without simplifications. So what they're gonna do, they try to split that reservoir into grids, and each grid hold a certain property, a single values. And that grid could be 1,000 cubic meters. Yep. And as long as 100 meters, and wide as 100, and the height is 100. And they give that piece of rock a single value, a single porosity value, a single permeability, let's say that 15%, permeability 10 millidarcy, whatever, and the fluid saturation, oil saturation, and also the water saturation. They give each grid a single value, and they use these values in the diffusivity equation, where they study how the performance and how the future of that reservoir are going to be changed. And this, giving a single value, will approximate the flow. And this is not the reality. The word true here is very critical. It depends on your future performance. It could be as correct as 80% or 90%. It depends actually on your geological and physical properties that you know about your reservoir. But when it comes to science, in physics, for example, say that the surface, and we have an object accelerate at the rate of 9.8 meter per second square. This is true and can be trusted actually, and with a good precision, and it is better than the previous example. But this physics law is not absolutely correct, and for the following reasons. Imagine that on that Earth's surface you have a mountain, and this mountain, if you drop the same object on that mountain, it won't accelerate at the same rate, because here the distance of the gravity is different, because the gravity, let's say that's the center of the Earth, okay? The distance between the center and the surface is not the same to the surface of that mountain. That's why the value of 9.8 meter per second square is an approximation. It could be also different even at an altitude of 100 meters. However, in mathematics, the word true is meant to be considered absolute, unconditional, and also without exception. And that's why mathematics is much stricter than other disciplines. Let us consider an example, the Pythagorean theorem. Let me just draw this triangle in the correct way. All right. Okay, let us consider that Pythagorean theorem. If in A and B, the legs of a right triangle, and C is the hypotenuse, and A square plus B square is equal to C square. Now, this law is true for every right triangle, absolutely and without exception. But also, a real right triangle only exists in our minds, because drawing of a right triangle is not a right triangle. Drawing is never accurate, even with the great precisions. You can't really get 100% accurate when it comes to drawing. That's why still mathematics is much stricter than other disciplines, but only exists in our minds. Thank you very much for watching.